What up, everybody? Complex circuits are complex, and so in this video I hope to show you the tools that you can use to solve any complex circuit. But I'll be going step by step solving this circuit right here. So we have a light bulb in one branch, and it kind of looks like a parallel circuit, but instead in this branch you have two light bulbs. Now if you want to look at this circuit instead, I've done it in another video. I suggest watching both of them to get a good idea how to solve complex circuits. I'll also, in another video, show you solving a circuit diagram, complex circuit, just with a pen and paper. So if you're interested in that instead, there's another video for that. But let's go ahead and get started on this circuit. So let's begin solving the circuit. As the name suggests, these circuits are complex. Right? There's different types of complex circuits, and no two types are solved exactly the same way, but we use the same tools to solve all of them, right? And so in this example, I'm going to use all the tools, and if you master these tools, you'll be able to solve any complex circuit out there. So here's the tools. One is a junction rule, another is a loop rule, combining resistors, and then Ohm's law, right? Ohm's law, you may have heard it different ways. Voltage equals current times resistance, right? If you're looking for the resistance, it's voltage divided by current. If you're looking for the current, it's voltage divided by resistance, right? So if you need help with any of these tools, we are making other videos, and there'll be links to those videos. But let's assume you already know those, right? And let's begin solving the circuit. So first of all, let's talk about the junction rule. The junction rule says that when the current splits up or comes back together at a junction, that the current in is equal to the current out, right? So this is T for total current. It comes from the battery, right? And it splits up into I1 and I2, which is the current that goes through this light bulb and the current that goes along this branch, and it will have to go through both of these light bulbs over here. So because the current comes in here, the current here has to be equal to both of these currents put together. All right. And then the current continues all the way around, and you can see it's going to happen here again, where these two currents from these two branches are going to combine and then give us a total current. So you can see that the current up here is equal to I1 plus I2, but so is the current down here. It's equal to I1 plus I2. So the current here and here are actually equal to each other, right? The same current. So this is going to be useful to solving things as we go. We're in the beginning, we're kind of collecting equations that we're going to use to solve stuff. So next, let's look at the loop rule. All right, and look at this green loop. This is a loop of current that leaves the battery, goes through this light bulb, goes back to the battery. The loop rule says that in any loop, that the voltage of the power sources, or in other words, in this case, the battery, is equal to the voltage drop across any resistors, right? So that the battery adds voltage to this loop, and then this one resistor is going to take away all of that voltage, right? So, and then there's another loop right here where it leaves the battery, goes through these two, and comes back. And in this case, the voltage supplied is 120 volts. The 120 volts is going to drop across these two light bulbs, and so the combined voltage drop for these two light bulbs needs to be 120. All right, so let's look at the first loop again. Okay, 120 volts, which means this light bulb here must have a voltage drop of 120. Right, so we'll just write that down there. And then Ohm's law says that current is equal to voltage divided by resistance. Right, and so the voltage is 120, the resistance is 40, and you divide those, you get the current. Okay, so the current is 3 amps, and let's be careful to define where that current is. That current is the current going through this light bulb. So it starts here and ends here. Okay, so you can't go beyond that point because then it combines with other currents. All right, but along this little branch right here, there's going to be 3 amps of current. Next, let's look at the larger loop where current goes through the 2 light bulbs on the far end of the circuit. All right, and so same thing, 120 volts is given by the battery. 120 volts are dropped across the resistors, which are the 2 light bulbs. Now, it might be tempting here to say, well, they must both get 60, right? And actually, that's going to be true, but it's not always the case that you split it in half, right? Because these are 2 identical resistors, but we could do another problem where they're different resistances and you get different voltages. So let me solve it the long way, because the long way will work for any circuit. Right, and that's going to be, we're going to combine resistors, right? Remember, that was one of our tools. All right, so we're just looking at this branch. And this branch has 2 40 ohm resistors. We're going to combine those just in our heads to be 1 80 ohm resistor. We can do that because these are in series with each other, right? And remember, resistors in series add together. And so these 2, because the current has to go through both of them. It can't like go through this one and not this one. So if that's the case, they're in series, you can add them together. So that's 80 ohms. And when you put that back in the circuit, right? So now it's kind of an imaginary circuit over here, but it's going to let us calculate what the current is because we want to know the current through here. There is a 120 volts that goes given by the battery. 120 volts has to go across this 80 ohm light bulb. And so let's find the current, which is just voltage divided by resistance. That'd be 1.5 amps. All right. So now we know that there's 3 amps through this branch. There's 1.5 through this light bulb. And I know this light bulb doesn't really exist. It's actually 2 different light bulbs. But that current extends all the way over. It starts here, all the way over here. All right. So let's take this back to where there's 2 light bulbs. We know still it's still 1.5 amps. Okay. And so we kind of use that trick to figure out the current. Right, so now how many volts go across each one of these light bulbs individually? We're going to use Ohm's law. Voltage equals current times resistance, which would be 1.5 times 40 for an individual light bulb, right, or 60. Right, so this light bulb here has 60 volts. And then we do the same thing down here, and that also gives us 60 volts. All right, so yes, they do split the voltage equally, and that's not surprising since they're the identical light bulbs. But if the top one had a larger resistance, then it would take more of the voltage. All right, and you'd be able to calculate that using the method that I just showed you. All right, that leads really only one thing we don't know, and that is how much current is here by the battery in this first branch. Right, before it branches out into the light bulbs, how much current is here. And to find that out, we're going to go back to the junction rule that we found in the beginning. And we know that this breaks up into 2 branches. One has 3 amps and one has 1.5 amps. And so if you add those together, you get 4.5. Right, and so 4.5 amps of current come out of the battery in this case. Okay, so we found all the currents, all the voltages, all the resistances. Now let's go ahead and check our work, all right? And we can use our tool box to check. All right, so first of all, the junction rule. 4.5 amps came in, 3 this way, 1.5 this way, and so that satisfies the junction rule, that the current coming in is equal to the current coming out, because 3 plus 1.5 is equal to 4.5. Then what about this junction down here? Okay, so you can look at any junction, and this should hold up. Right, 1.5 comes in this way, 3 comes in this way, and then they add up to 4.5, which is the total current. Now loop roll. All right, 120 volts is given by the battery. 120 volts is used by the light bulb, right there. Then in the larger loop, 120 volts given by the battery. All right, you see there's a 60 and a 60 that adds up to 120. So 120 are used by the light bulbs. All right, and so all the the physical laws of circuits are satisfied with our solution, and so we got it right. All right, thanks for watching this video. If you want to see this problem solved on paper with just a pen and paper and circuit diagram, click on this link and you'll be able to watch that. See you again.